Okay, so for the topic number 2, we are going to discuss program translation with regards to uh, compilers, interpreters, assemblers. Okay, so uh, on the previous topic, we have discussed the ano, data abstractions and the difference between high level and low level programming languages, as well as the generations of programming languages. Now, as we know, yung uh, composition ng programming language uh, tends to be more uh, high level or simply uh, far away dun sa machine codes, right? Now, ang program translation concerns with interpreting those commands, no? Uh, Pag-uusapan natin yung natin paano ba kino-convert yung programming languages given the codes written in uh, tawag dyan, non-binary ano. So paano ba siya i-convert? So ito yung tinatawag na program translation. So basically we need to translate these given commands to uh, for the computer to understand kung ano yung gusto nating ipagawa sa kanya. So modern day programming languages attempt to give programmers the capability of doing complex things with the computer while writing instructions for the computer in a language close to their own natural language. So basically, di ba dun sa generation ng programming languages, uh, specifically dun sa 5th generation, we tend to um, create languages that are more English-like statements, no, rather than uh, close to uh, machine code or yung low level uh, languages. And so for example, so so para pag-focus tayo in writing instead of uh, ano yun, memorizing or debugging yung ating mga programs. And so for example, most programmers are comfortable enough with standard mathematical language to use such expression kagaya ng, for example, ito ay formula for volume of a pyramid. Ano? So 1/3 times the length multiplied by the base width multiplied by the height. So mas komportable tayo if we define the formula dun sa ating program using this instead of machine code, right? So they do not care to know the sequence of machine instructions that is needed to evaluate this expression, much less the machine coding for those instructions. So that's why programming languages tends to be high level or yung close din sa ating natural language or mostly English-like statements. So therefore, kailangan natin siya i-translate into machine code. Also, when a programmer wants to specify a numerical value, they prefer to specify it as a string of decimal digits rather than machine binary code. Now, so imagine kung magpo-program tayo dun sa talagang first generation, you needed to memorize sequence of binary code. No. Furthermore, a programmer has no interest in character coding for the decimal digits. Kagaya nung sa ASCII codes, ano. So, for example, 0, ano nga ba yan? 046. And so, di ba merong dun sa ASCII code chart, meron dun a specific value para dun sa mga characters. Okay? So, instead na yun yung dinedefine natin sa programming. For example, yung mismong code na yun, edi as simple as letters na lang. So, thus programming languages require powerful mechanism for translating those languages given by the programmer into a language that the machine can understand. So, basically, we needed those languages, yung mga sinusulat natin sa program, to machine code. Because computer nga can only understand binary. And so, this is the basis in the code translation. So, before siya ma-execute sa processor, from the high-level languages, so most of the programs are written in high-level languages. So, we need to convert it as much as possible into let's say assembly language, or to the level na gagamit tayo ng compiler para ma-convert siya one level down, and then if needed, kailangan natin na assembler para convert natin siya into machine code or yung binary. And so those are yung instructions na natin. Then bago natin siya ma-send sa processor for execution. Okay? So yan yung pinagdadaanan ng program bago siya ma-execute sa processor. So let us define translators. So the most general term, these are the most general term for a software code converting tool. Yun. So yun yung definition niya. The term we use to describe a software code converting tool. Ang tawag sa kanya ay translator. So a translator in software programming terms is a generic term that could refer to either it is a compiler, assembler, or interpreter. Okay, so later on, i-discuss natin ano ba itong tatlong to. So anything that converts higher level code into another level code, kaya so ito yung mga example programming languages, yung Basic, C++, Fortran, Java. So yun, high level languages. And then we have low level languages, kagaya. So basically, these are the language that the processor can understand, and such as assembly language saka machine codes. So these are languages that are needed to be translated for into a much lower level language, either assembly or machine code. So definitely dapat machine code para maintindihan ng computer. Okay, so historically there have been two primary approaches to the problem of translating program languages into machine language. I think ito ay kasama dun sa discussion natin dun sa first topic, wherein we convert an example code into from assembly to machine code. And so yung mga nabanggit natin kanina, these are actually types of translators. Okay, so for us to translate the given programs, we either use a compiler, interpreters, or assemblers. So we will discuss the difference of those three. So first one, we have compilers. So compilers convert high-level language code to machine code, or sa ibang references, ang tawag dito ay object code, into one session. So compilers can take a while because they have to translate high-level code to much lower-level machine languages all at once and then save the executable object code to a memory. So a compiler creates machine code that runs on a processor with a specific instruction set architecture, or yung ISA, which is a processor dependent. Okay, so ang difference ng compiler sa interpreter sa assembler is dito kino-convert niya yung given program into machine code all at once. Okay, and then nagke-create siya ng executable object code na sinesave niya, so gumagamit siya ng memory. Okay, so later on i-compare natin yung tatlo. And so for example, you cannot compile code for x86 and run it on a MIPS architecture without a special compiler. So basically dito ang sinasabi lang, what do we mean by processor dependent? So definitely hindi siya independent. So naka-depende siya sa processor. So hindi gagana yung compiler natin kapag hindi siya compatible dun sa processor. And so sa example natin dito, hindi natin pwedeng i-compile yung code intended for x86 tapos gusto natin siya i-run from 2 pips. Okay, so yun yung ibig sabihin natin ng processor dependent. So dapat compatible yung compiler na gagamitin mo sa mismong system architecture. So therefore, compilers are also platform dependent. So for example, a compiler can convert C++, for example, to machine code that's targeted at a platform that's running the Linux OS. So hindi lang sa processor, pati sa platform. Okay, so kung pan Linux yung compiler, pang Linux. Otherwise, hindi siya gagana. Although we have yung mga tinatawag na cross-compiler that can generate code for a platform other than the one it runs on itself. And so each compiler can provide or generate codes kasi in different processor, different platforms. Ayan. And so let us have yung interpreters. So another way to convert code to run on your processor is by the use of an interpreter, which is not the same as the compiler. So an interpreter translate code like compiler. So parehas lang sila ng task. Nagta-translate tayo ng given program written most likely in high-level languages. We tend to translate them into much lower language or specifically to machine codes. And so like a compiler but reads the code and immediately execute on that code, and therefore is initially faster than compiler. So in terms of speed, mas mabilis ang compiler ang interpreter compared sa compiler. Di ba kanina ang sabi natin ay ang compiler kasi tinatranslate niya muna lahat bago niya i-execute. Ang interpreter, on the other hand, translate each code line by line and immediately execute them. Okay? So, thus, interpreters are often used in software development tools such as debugging, as they can execute a single encode at a time. So, mas applicable siya if we want to develop a software na mas malakas yung support sa debugging. Kasi every time, or rather, before ma-execute natin yung buong program, i-check niya muna line by line. And we cannot actually proceed with running the program without even correcting yung mga syntax errors. Okay? So compilers translate code all at once, and the processor then execute upon the machine language that the compiler produce. So definitely that is in contrast to interpreters. Okay, so if changes are made to the code after compilation, the change code will need to be compiled and added to the compiled code, or perhaps the entire program will need to be recompiled. So yun yung parang this statement only describe the disadvantage of compiler. So kapag merong changes sa code, kailangan i-compile uli siya. So basically, ulitin niya uli yung process. And then, yun, yung buong program at i-recompile niya. Okay? So, compared dun sa interpreter, although skipping the step of compilation of the entire program to start is much slower to execute than the same program that's been completely compiled. So dito yung pinag-uusapan natin is in relation to pag-reuse ng yung second time running ng program. Kasi sa compiler, since meron na tayong compiled, interpreted program, yun na lang yung gagamitin. No? Pero dito sa interpreter, every time na irara natin yung program, i-translate niya uli. So, let's say, mahaba yung program natin, no? So, sa compiler, although mabagal siyang mag-execute, sa mga susunod na time na magra-run siya, dahil meron tayong save file ng translated code, yun na lang yung tatawagin. Not unlike yung interpreter na ang disadvantage nito is kapag multiple time natin iraran, there is a possibility na pag mahaba yung program na itatranslate, edi mas mabagal na siya. So interpreters, however, have usefulness in areas where speed doesn't matter, like debugging and training. Okay, so pag nag-identify tayo ng system error, hindi naman importante na mag-execute kagad yung program kasi we needed to be sure if the syntaxes are correct, diba? And so it is impossible to take the entire interpreter and use it on another ISA, which make it more portable than compiler when working between hardware architectures. So compared dun sa compiler kanina, this one naman is independent, no, in terms of processor. And so compatibility wise, mas mas portable ang interpreter compared sa compiler. And so, let us differentiate compilers and interpreter. So the most distinguishing characteristics of a compiler is that it is used once to translate program into machine language. Another, the machine language is saved in a file so that it can be executed as many times as you want without having to be translated again. So since gumagamit nga siya ng save file, hindi na natin siya needed to i-translate. No, pwedeng tawagin na lang uli natin yung save file. So this allows program execution at full speed of the computer processor by eliminating translation overhead. So the drawback is that the translated program can only run on the family of processor for which the compiler was designed. So again, hindi siya independent. So processor dependent siya. So depende siya sa processor. And while the distinguishing characteristic of an interpreter is that it translates a program into machine language every time the program is executed. Okay, so there is no save translation or walang file. If an interpreter is written for each machine, then you can move the program from one machine to another and still expect it to execute correctly. So portable yung ating program. It is important to note that even though you need a different interpreter for each machine, the interpreter is the only software that is not portable. Programs written in the language for which the interpreter is designed are portable. So yung interpreter itself ay hindi portable, pero yung program written dun sa language ng interpreter na yun ang portable. Okay, the drawback of interpreter is that the program is translated into machine instructions every time it is executed. So, medyo mabagal siya in terms of paulit-ulit na translation. So, this can slow down execution by factor of few hundreds or depende kung gaano kahaba yung program. And so basically, siguro what you can notice is meron na kayong mga ginawang program before na hindi kayo ina-allow or hindi ina-allow na mag-run yung program nyo without correcting yung syntax error. So that uses interpreter. Okay? Kasi before mag-execute, na-identify na or na-translate na yung mali. While yung compiler, during runtime, nag-error kasi dun pa lang nade-detect yung syntax error. Okay? And so, between those three, cannot actually compare the two sa assembler kasi assembler is separate case. So this is specifically intended for assembly language. Okay, so an assembler translate a program written in assembly language into machine language. Actually mas konti na lang, no, di ba dun sa level natin kanina. And so either we use compiler or interpreter dito sa high level languages. Okay, while sa assembler, nandito na siya, one step down na siya ng assembly language. So it just needed an assembler for it to be converted into machine code. before execution sa processor. Okay, so ayun, so we have another type of translator, but this is intended for assembly language na level. So it is effectively a compiler for assembly language, but can also be used interactively like an interpreter. So assembly language is a low-level programming language. And so i-recall lang natin what do we mean by low-level programming language. So when we say low-level programming language, these are less human-like language in that they are more difficult to understand at a glance. So let's say ito yung hindi siya typically machine code or binary, ano. There are letters that are similar to human language. So you have to study assembly code carefully in order to follow the intent of execution, and in most cases, assembly code has many more lines of code to represent the same function being executed as a higher level language. So in terms of length, mas mahaba yung assembly code. So an assembler converts assembly language code into machine code, also known as object code. So it is an even lower level language that the processor can directly understand, yung machine code. Okay. So assembly language code is more often used with 8-bit processors and become increasingly and widely as the processor instruction set becomes. And so it is not impossible for people to read machine code. The strings of ones and zeros that the digital devices, including processor, use to communicate, but it's likely only read by people in case of computer forensics or brute force hacking. Kasi imagine, marunong ka magbasa ng ones and zero or yung machine code. But definitely you have a background knowledge in assembly language for you to really understand or read machine code. So assembly language is the next level up from machine code and is quite useful extremely cases for debugging code to determine exactly what's going on in a problematic execution, for instance. And so now let us take a look on yung summary ng tatlo. Okay? So and so yung first row natin dito simply means what is being translated. So sa compiler, we use this to translate high-level language into machine code. Sa interpreter, we temporarily execute high-level languages one statement at a time. Okay? Sa assembly, we translate low-level assembly code into machine code. And so next one, in terms naman kung meron bang object code or file na ginagamit. So sa compiler, there is an executable file or machine code. Sa interpreter, wala. Once na matranslate natin siya, and that's why it is temporary, hindi natin siya sinisave. No, so there is no executable file. Directly natin siya. And although sa assembler, there is a file, executable file, or what we call object code. And so para siyang compiler, pero in some cases, para din siyang interpreter. And, but again, assembler is used for converting assembly code to machine code. Okay, so next. And so sa compiler, compiled programs no longer need the compiler kasi naka-compile na siya. Okay, so hindi mo na kailangan ipadaan ulit sa compiler. While interpreted programs cannot be used without interpreter because every time we needed to execute that, kailangan i-translate siya ulit. Assembled programs no longer need assembler. So basically, dahil meron din silang executable file na. Okay? And, pero dito, dahil wala siyang executable file, kailangan natin uli ng interpreter para dun sa mga programs na design for interpreter. And so, I think this one it talks about ano yun? Sa error. And error report produced once the entire program is compiled. These errors may cause your program to crash. Okay? So, kagaya nung nabanggit ko kanina, sa compiler kasi, it allows you to run the program. Now, during the runtime, dun natin ma-experience yung mga errors. So, it tends to therefore our programs tends to crash. Okay? So kasi sa pag na-compile nandun pa lang kakaroon ng error report. While sa interpreter, error messages produce immediately and the program stops at that point. So it doesn't allow you to run the program not unless meron pang natitirang error message. Okay, so next we have assembler. So one low-level language statement is usually translated into one machine code instructions. Yan, tapos wala na siyang comparison dito. Okay, so ito na lang yung tapusin natin. Sa compiler, so in terms of speed, compiling may be slow, but the resulting program code will run quick. So directly sent to the processor. While sa interpreted code is run to interpreter, or if you are familiar dun sa IDE, ayan yung ano nga yun? IDE stands for environment, no? So yung wait lang, let me have my note. And so again, in terms of speed, mabagal yung compiler, pero sa second time around, nag-run siya ulit, di mas mabilis na. And so IDE stands for Integrated Development Environment. So these are used for building application that combines common developer tools into a single graphical user interface. And so mostly ginagamit yung IDE yung sa Java, right? And so it may be slow and to execute program loops. And so sa compiler, one high-level language statement may be several lines of machine code when compiled. So in terms of composition, maraming lines of codes na nagki-create or nata-translate sa machine code using compiler. Okay, so that will cover yung ating topic number 2. We will further discuss ayan. For the topic number 3, kindly keep posted. I think pag-usapan natin soon ay yung type systems. Okay?